Imagine holding a small piece of chalk in your hand. It feels light, soft, and almost ordinary. But here's what nobody tells you. Before it reaches a classroom, a sports field, or an artist's studio, that little stick begins a journey deep inside the earth that took millions of years to create. Today, we're stepping inside that hidden world to discover how chalk is really made. Think about this. Every line written across a blackboard starts with ancient microscopic sea creatures that settled on the ocean floor millions of years ago. Over countless ages, their tiny shells compressed into thick layers of chalk rock. What happens next surprised even experienced engineers, because nature does most of the hard work long before factories ever begin. Modern chalk factories combine geology, chemistry, precision engineering, and skilled craftsmanship. Every batch must feel smooth, write clearly, and break in a predictable way. A tiny mistake in the recipe can turn perfect chalk into fragile dust. And that raises an important question. Where do manufacturers find material pure enough to meet those standards? Our journey begins in enormous open-pit quarries where brilliant white chalk stretches across the landscape like frozen snow. Some deposits reach more than 98% calcium carbonate, making them ideal for premium classroom chalk. Giant excavators slowly peel away layers that have remained untouched for tens of millions of years. Most people never imagine that a school supply starts in a mine this massive. Some of the world's highest quality natural chalk comes from England's famous White Cliffs of Dover region, France, and parts of Denmark. Other manufacturers rely on carefully refined limestone from countries such as China, India, and the United States. Depending on the factory, raw materials may travel hundreds or even thousands of kilometers before production begins. And every shipment must meet strict purity standards before it moves any farther. After blasting or mechanical excavation, enormous rock crushers reduce the chalk into smaller pieces. Conveyor belts carry the material toward grinding mills where powerful steel rollers crush it into an incredibly fine powder. As the machines roar, clouds of brilliant white dust swirl through enclosed systems while industrial filters capture nearly every airborne particle. The smell is clean, dry, and earthy, like freshly broken stone after rain. Before manufacturers accept the powder, laboratories test every batch for purity, moisture, and particle size. Even a small amount of unwanted minerals can change how smoothly chalk writes or how easily it snaps. Advanced analyzers inspect microscopic samples while technicians compare results against strict quality limits. But here's where the story becomes even more fascinating. Powder alone can't become perfect chalk. The purified powder now waits for the most important transformation of its entire journey. In the next stage, engineers will blend carefully measured ingredients, control moisture with incredible precision, and shape thousands of perfectly uniform chalk sticks every single hour. What looks simple from the outside hides an astonishing manufacturing process that very few people ever get to see. The moment the purified chalk powder enters the mixing room, everything changes. Computer-controlled systems weigh every ingredient with incredible precision because even a tiny error can ruin thousands of chalk sticks. Most manufacturers blend high-purity calcium carbonate with clean water and a carefully measured binder such as gypsum or starch-based additives. Imagine standing beside the giant mixers as the dry powder slowly transforms into a smooth, creamy paste. Inside the mixer, heavy-duty paddles rotate at approximately 40 to 80 revolutions per minute, blending the mixture for 10 to 20 minutes. The process takes place close to room temperature, around 20 to 30 degrees Celsius, 68 to 86 degrees Fahrenheit, while moisture sensors constantly monitor the consistency. The paste must become perfectly smooth with no visible lumps because every tiny imperfection could weaken the finished chalk. What happens next surprised even experienced engineers. The fresh paste travels through enclosed pipes into automated molding machines. Hydraulic pumps apply gentle pressure of around 2 to 5 bar, 29 to 73 psi, pushing the mixture into long precision molds. Every cavity has exactly the same dimensions, allowing thousands of chalk sticks to form with remarkable accuracy. The machines move with quiet precision while the factory echoes with the steady hum of motors. As the molds fill, tiny air bubbles rise to the surface and disappear. Vibrating tables shake gently for 20 to 40 seconds, helping the mixture settle evenly into every corner. Without this step, hidden air pockets could cause the chalk to crack during drying. Most people never think about this invisible detail, yet it makes all the difference. Now comes the waiting game. The filled molds move into controlled drying chambers where warm air circulates at approximately 40 to 60 degrees Celsius, 104 to 140 degrees Fahrenheit, for 8 to 24 hours, depending on the chalk formula. Fans move air evenly through the room while humidity sensors prevent the chalk from drying too quickly. The air feels warm and dry, carrying the faint mineral scent of freshly formed chalk. Once fully cured, automated ejectors gently push each chalk stick out of its mold. Robotic arms lift hundreds of perfectly shaped pieces every minute and place them onto high-speed conveyor belts moving at nearly 0.5 meters per second. Watching thousands of identical white chalk sticks glide across the factory floor feels almost hypnotic. But the journey isn't over yet. Before a single stick reaches a classroom, rotating polishing drums remove tiny rough edges without damaging the chalk. Soft brushes sweep away loose dust while powerful vacuum systems collect every particle for recycling back into production. Almost nothing goes to waste, making the process both efficient and environmentally responsible. And this is where the story gets truly extraordinary. The chalk now looks complete, but appearances can be deceiving. Hidden flaws smaller than a grain of sand can still cause a stick to snap in someone's hand. In the next stage, advanced robots, laser scanners, AI cameras, and skilled inspectors will examine every piece with astonishing precision. That's where the real challenge begins. As thousands of chalk sticks speed along the conveyor, high-resolution AI vision cameras inspect every single one in real time. Powerful LED lights reveal tiny cracks, chips, stains, and uneven surfaces that the human eye could easily miss. The system scans hundreds of pieces every minute, making split-second decisions without slowing production. But here's what nobody tells you. Even the smartest machine still needs human experience. Laser scanners measure every chalk stick with astonishing precision. Most premium manufacturers keep length and diameter within a tolerance of about plus or minus 0.2 millimeters, ensuring every piece fits perfectly inside its packaging. If even one stick falls outside the limit, automated air jets instantly remove it from the production line. Watching dozens of rejected pieces disappear in a fraction of a second feels almost unbelievable. Next comes the strength test. Mechanical testing machines gently bend and compress random samples to make sure they can survive shipping, storage, and everyday classroom use. Engineers carefully record the results because chalk that breaks too easily creates waste, while chalk that's too hard won't write smoothly. Finding the perfect balance takes years of manufacturing experience. Not every test happens inside a machine. Experienced quality inspectors still pick up random chalk sticks by hand, feeling their texture, checking the finish, and writing on special blackboards. They listen for the soft scratching sound and watch how evenly the chalk leaves its mark. In this one important moment, human skill still beats automation. After passing inspection, robotic packaging systems arrange the chalk into perfectly aligned rows. High-speed machines wrap, seal, and label each box, producing thousands of retail packs every hour. Barcode scanners verify every package before it leaves the factory, ensuring complete traceability from raw material to customer. Every box tells the story of an extraordinary manufacturing journey. Many leading manufacturers operate under internationally recognized quality systems such as ISO 9001, where every production stage follows carefully documented procedures. Sensors continuously monitor production data, helping engineers detect problems before they become expensive defects. In many factories, fewer than 2% of chalk sticks fail final inspection thanks to these advanced controls. Most people never realize how much science hides inside something so simple. Now the finished boxes roll toward loading docks, ready to begin another journey across the world. Schools, universities, sports stadiums, artists, and factories will soon use these simple white sticks without ever seeing the remarkable technology behind them. But one final mystery remains. Just how many chalk sticks does the world produce every year? And which countries lead this surprisingly massive industry? Imagine millions of classrooms, sports stadiums, factories, and art studios using chalk every single day. Around the world, manufacturers produce billions of chalk sticks every year, supplying education, construction, industry, and creative arts. The global chalk and related writing materials market is worth hundreds of millions of US dollars annually, with demand remaining strong despite the rise of digital technology. Something so small still plays a surprisingly big role in everyday life. China, India, the United States, Germany, and Japan rank among the world's leading producers and consumers of manufactured chalk and chalk-based educational products. Massive automated factories operate around the clock, shipping products across continents by truck, rail, ship, and air. Every shipment begins with ancient minerals and ends in someone's hand thousands of kilometers away. That journey often takes weeks, yet the final product weighs only a few grams. Did you know? The chalk used on sports fields is often specially formulated to stay bright and highly visible in changing weather. Did you know? Premium artist chalk uses carefully controlled pigments to produce rich, vibrant colors. And here's another surprise. Modern dustless chalk dramatically reduces airborne particles, making classrooms cleaner and more comfortable than ever before. Over the last 50 years, chalk manufacturing has transformed from labor-intensive workshops into highly automated production facilities guided by robotics, AI inspection systems, and precision engineering. Factories now recycle waste material, reduce dust emissions, and improve energy efficiency while producing more consistent products than ever before. Looking ahead, smarter automation and sustainable manufacturing will continue shaping the future of this timeless product. Even after centuries of use, the story of chalk is still being written. We've traveled from ancient seabeds to giant quarries, through precision factories, advanced laboratories, and global shipping networks. What seemed like an ordinary classroom tool turned out to be the result of geology, engineering, science, and skilled craftsmanship working together. The next time you see a piece of chalk, you'll know it carries millions of years of history and countless hours of human innovation. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factor.